Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 2 for 2018, and I'm going to have a look at questions 1 and 2. So question 1 involves this circle here with centre O. There are 5 points, A, B, C, D and E on the circle, and AB and DE are both diameters. They go through the centre O. The angle BOE is 40 degrees, and the angles X, Y and Z are all marked. So we've got to answer these questions. First one, write down the size of the angle X. The size of the angle X. So let me just get rid of that. Size of the angle X is just going to be 40 degrees because it's vertically opposite. So it's vertically opposite the angle BOE. Okay, second question, work out the size of the angle Y. So this angle here, Y. Now, if you look at this triangle here, you'll notice that this here is a radius and this here is a radius. So this is a radius and this is a radius, so they're both equal. In other words, this triangle here is actually an isosceles triangle. So we know that X here is 40 degrees. So this is 40 degrees here. So all we got to do is subtract 40 degrees from 180 degrees. That will give us these two angles here. But we know because it's an isosceles triangle, these two angles are equal. So we just got to divide by 2 to give us Y. So the way we're going to do this, we're going to take 180 degrees. So we're going to take 180 degrees. We're going to subtract 40 degrees. That will give us 140 degrees. And then we're going to take 140 degrees, divide by 2, and that will give us 70 degrees. So 70 degrees then is just equal to the size of the angle Y. So that's part 2, or part B here. So let's have a look at part C. Part C, work out the size of the angle Z. So let's look at angle Z then. Okay, so angle Z is actually up here, and there are a couple of ways of doing this. One way of doing it is to look at this quadrilateral here. We've got A, B, C, D. This quadrilateral here is what's called a cyclic quadrilateral. In other words, a circle can be drawn around it so that the circle goes through each of the 4 vertices. And the thing about cyclic quadrilaterals is that angles opposite each other add up to 180 degrees. So we've already worked out Y here as 70. So the angle opposite Y is Z. So that would be just 110 degrees then. Another way of doing that would be, let's see, we know that this is 40 degrees here. So that would mean that this angle here would be, let's see, that's 180 degrees. So this would be 140 degrees here. Now, let me just think. That means, yeah, if this is 140 degrees here, that means this angle around here would be 360 degrees minus 140. So 360 minus 140 is 220 degrees. So let me just write that in. So 220 degrees would be from here to here. We're looking at this angle here. Now why am I saying that? Well, if you notice this angle of 220 degrees here, it's actually sitting on the arc DB. It's sitting on the arc DB. But so is Z. Z is also sitting on the arc DB. Now the angle 220 is at the center. the angle Z is at the circle. They're both standing on the same arc. Therefore, the angle Z is half the angle sitting at the center here on the same arc. So the angle at Z would be half 220, which is 110. Probably the easiest way would be the first way I showed you. We have this cyclic quadrilateral here. Opposite angles add up to 180 degrees. We know Y is 70, therefore Z must be 180. So let me just write that out. So we know that, let's see, we know that the angle Y, the angle at Y, is equal to 70 degrees. We could write down opposite angles in a cyclic quadrilateral add up to 180 degrees. Okay, so opposite angles of a cyclic quadrilateral add up to 180 degrees. Therefore, angle Z is equal to 180 degrees minus 70 degrees, which is equal to 110 degrees. And that's really it for question 1. Let's have a look at question 2 here. Question 2 here is to do with these boxes here. This is one of many boxes. So we have, let's see, a new action camera is sold in a box that is 5 centimeters high, 14 centimeters wide, and 24 centimeters long. Work out the volume of this box. So this is a fairly straightforward question. The volume of a cuboid is just going to be length times width times height. So in this case it's going to be 24 times 14 times 5. So 24 times 14 times 5 is 1680. Now we're looking at centimeters and we're talking about volume, so it's centimeters cubed. Okay, so that's the first one, fairly straightforward. Now, second one then, part B, 36 of these boxes are packed together and a cover that is 1 centimeter thick is put all around the outside of the 36 boxes as shown. Work out the outside dimension of this cover. So we have, let's work this out then. Let's just work out the width first. So the width is going to be, we've got 3 of these boxes here, and we know that the width from up here and back up here again was 14 centimeters. So the width was 14 centimeters. So in this particular case we've got 3 of these 14s. That'll bring us from here to here, and then we've got 2 centimeters on either side, so you've got to add 2. So when you do that you get 44 centimeters. Let's look at the height next. Okay, so the height was, let me just have a look back up here again. So we have, the height was 5 centimeters. So the height was 5 centimeters initially. So how many of these do we have? 1, 2, 3, 4. We've got 4 of these. So you've got to do 4 of these 5s. And also we have a centimeter on the bottom and a centimeter on the top, so we've got to add 2 as well. So that'll give us 22 centimeters. So let's look at the length next. So the length was 24 centimeters, and we have 1, 2, 3 of them. So we've got 3 of these 24s, and again we have 2 centimeters on either end. So that will give us 74 centimeters. So we got to work out, is that all we had to do in this question? Work out the dimensions only. So work out the outside dimensions of this cover in centimeters. So we've done that. Okay, so the next one then, now we've got to work out, let's see, the cover that is put all around these 36 boxes is made of plastic. So work out the volume of this plastic cover. So we've got to work out the volume of this plastic cover. So a couple of ways of doing this, but what we could do is try to work out the dimensions of the plastic cover on its own. But probably the best thing to do would be, the easiest thing to do would be to work out the volume of the entire cuboid, including all the boxes in between. Work out the volume of all the boxes in the middle, and then subtract the two. That will give us the volume of the plastic. So that's the way I'm going to do it. So I'm going to work, first of all, we have the width, the length and the height of the entire cuboid, so I'm going to work out the entire volume first. Then we'll work out the volume of all these boxes in the middle, then subtract. So let's do that. So we have, let's call it the total volume. So the total volume is just going to be 44 times 22 times 74. So if you work that out, you get 71632 centimeters cubed. Now we want to work out the volume of the 36 boxes. So the volume of the 36 boxes, well, we've worked out, I think up here somewhere, yeah, the very first thing we had to do was work out the volume of one of the boxes, so it's 1680. So all we got to do is take that 1680 and multiply it by 36. So if you do that, you get 6480 centimeters cubed. So that means then that the volume of the plastic is just going to be 71632 minus 6480, and when you do that you get 11152 centimeters cubed. Okay, so that's it.